All right, so Unit 8 is about chemical bonds. But the first thing to know about chemical bonds, the first thing we need to understand is the octet rule and kind of what it's based on. And if we go back and we look in Unit 7, when we talk about groups and periods, that's section 7.4 and 7.5. I think 7.4 that we talked about that. That really comes into play here when we talk about the octet rule. But the octet rule describes why or how atoms combine to make substances. Now, way earlier in the school year, we talked about the fundamental forces of nature. We said that there were four fundamental forces. We said gravity and electromagnetism. We talked about the strong nuclear force and the weak nuclear force. Here, we see how electromagnetism comes into play. Now, you guys are familiar with magnets. You know that a magnet will stick to your refrigerator, for example. But that same force is what's responsible for holding together the atoms that make your skin, the refrigerator, all of the things. If atoms are combined together, they are combined together electromagnetically. So this is the force that is at work here, and it all depends on the electron shells that we've already learned about. So quick review. Atoms are made up of the protons and neutrons in the nucleus, okay? For our study of science, we're sort of done with that. We're not going to worry too much about protons and neutrons anymore. From here on out, we're going to focus on the electrons and the electron shells, and that's where chemistry happens. Anytime you have a change in matter, anytime matter changes and it deals with protons and neutrons, you're talking about things like nuclear explosions and things of that nature. We're not getting into that in a high school physical science class. We will talk about chemistry though, and chemistry takes place with electrons. It takes place here on the outer shells of electrons, where atoms give up and take electrons and form chemical bonds, and that's where chemistry takes place. Our first term is valence shell. And the valence shell is just that outside shell. Okay, that outside shell is where we got the idea for which group an atom is in on the periodic table. Okay, the valence shell tells us that. And how many shells total it has, that tells us what period it's in. But we're not really worried about that as much anymore either. So we're just worried about how many electrons are on the valence shell, or the outside shell of an atom. And we remember, this is just a callback slide to the periodic law. It talks about more electron shells as you go down, more electrons on the outermost shell, on the valence, let's call this valence shell, as you go across. And then another callback, we go back to Unit 5, I believe it was, where we talked about substances and mixtures. Mixtures, of course, you can separate a mixture with physical means, okay? You can physically pick the red Skittles out from the blue Skittles from the green Skittles, right? You can separate that mixture. You can even, you can separate the sand and the salt water from each other with physical means, okay? Substances can be separated by physical means, but the stuff we're talking about from here on out, these are things where the atoms themselves are magnetically attached, okay? They are attached with chemistry. They are chemically combined. And so the things we're going to talk about now are compounds. We're going to talk a lot about compounds, how elements come together to form compounds. And compounds are things that you can't sort out. You can't break them or filter them. You need chemistry to take them apart. Okay, so substances are made of molecules. Okay, this is a magnifying glass held up to some water here, and you can see the water molecules. Now, in real life, there's no magnifying glass strong enough to do this. This is just kind of illustrative. But molecules are the connected atoms that make up an element or a substance. So it is this hydrogen atom, this oxygen atom, and these two hydrogen atoms attached to it. That is the molecule of water. And again, they connect by electromagnetic forces. You can see the negatively charged um, oxygen atom and the two positively charged hydrogen atoms. We'll get into this in specifics as we go on here. So at this point, I'm actually going to pause my recording and I'm going to show this video and then I will record again. I would invite you to go and look up this video. I'll pull it up just so you can see what it's called here. It is Chemical Bonding, Ionic versus Covalent Bonds, and it's by Ricochet Science. I highly recommend viewing this again and again until you understand this concept, because I will be asking questions about it. I'm going to pause my recording. Okay, so that gives us a quick picture of ionic versus covalent bonds, okay? But basically what happens is atoms don't want anything, of course. They're not people or animals even, but we can say that atoms have a tendency to have 8 electrons in their outer shell, or in the case of hydrogen and helium, 2 electrons in their outer shell. But atoms want 8 electrons in their outer shell, and in order to achieve that, they will combine with other atoms so that all of the atoms in a molecule have their octet satisfied, okay? So if we look at our periodic table, we're going to pull up P table here. Look at our periodic table. Fluorine has 7 electrons in its outer shell. And so it's really, really, really going to want to combine with atoms that have 1 electron in their outer shell. It'll have a really strong tendency to do that. Fluorine will just gobble up lithium atoms. And actually, when that takes place, you have a pretty violent explosion. But atoms want to have 8 electrons in their outer shell. And fluorine, chlorine, bromine, iodine, they will really attack lithium, sodium, potassium, rubidium, and so on. Okay. Now, it's not just 2 atoms at a time that will combine to do this, though. Sometimes you'll have an atom like carbon, right? And carbon has 4 electrons on its outer shell, as the video showed. And carbon will attach to atoms that have 1 electron on their outer shell. So hydrogen, for example, carbon will attach to 4 hydrogens, right? And when it does that, it forms a compound we call methane, which is kind of cool. We'll be doing methane decomposition later on, and at the end of this unit, we'll be looking at that. But the big thing we need to know is that atoms want 8 electrons in their outer shell, and they will beg, borrow, and steal. They will even share in order to do that. So we've got an idea how it happens. So the first question here is, how many electrons does the outer shell of most atoms hold? Well, they will hold up to 8. They will hold up to 8 electrons. And some atoms are chemically stable because atoms like neon already has 8 electrons in its outer shell. That's what this means right here. It has 8. Actually, all of the noble gases have full outer shells. Their outer shells are full. They are complete. And what this means is that noble gases, well, they will not combine with other atoms to satisfy their octet. They're just not interested. Okay? So when atoms are chemically stable, they have 8 electrons in their valence shell, or their outer shell. And the rule for this, we have a name for this rule. This rule is called the octet rule. The octet rule. In the video, very briefly, it mentioned that covalent bonds form when atoms share electrons. Now, I'll let you guys in on a little secret. Fluorine doesn't share electrons. Chlorine doesn't really share electrons. Lithium, it can't share electrons. It doesn't hold its electrons tightly enough. So when fluorine pulls on the electrons of lithium, it just rips them off. And when it rips them off, lithium will get a charge. Okay. Now, if atoms are sharing electrons, it's because the atoms are able to hold them very tightly. And it's actually these elements, these other nonmetals, most commonly. It is nonmetals that you will find will participate in covalent bonds. Covalent bonds are bonds where they have a covalent. They share their valence, like a blanket. It's like two people sharing a blanket, okay? When fluorine attaches itself to lithium, it steals the blanket. It steals the electron. But when nitrogen and oxygen combine, they will share electrons. It will be a covalent bond because nitrogen holds electrons very tightly. Oxygen holds electrons very tightly. And if they're going to combine, they'll do it in a covalent bond. So covalent bonds form between nonmetals when they share electrons. And that is the only time you will find covalent bonds forming. Okay. So if there is a metal involved in the bond, if you have a bond that includes any of these elements over here, okay, it is not a covalent bond. Okay. Iron can't participate in a covalent bond. It can participate in a metallic bond, which is a third type we won't get into, because electron shells get funny with metals, but it will not participate in a covalent bond. An ionic bond forms between metals and nonmetals. And metals give up okay. When a metal gives up an electron, it is called an ion. A charged atom is called an ion. When a nonmetal takes an electron, it is an ion. And there are more specific terms for these, but we're not going to really get into that. Okay. So just going back, what are substances? Substances are materials. They are matter that can't be separated by physical means. If you want to separate a substance, then you need to basically you need to provide an opportunity for the atoms in a molecule to better satisfy their octet rule. And that we get into more specifics with that in later chemistry. Why some atoms tend to want to hook to other atoms even more, and how you can separate substances, separate compounds, but they can't be separated by physical means. And molecules, of course, they are the connected atoms that make up an element or a substance. They're connected by electromagnetic forces. And the valence electrons are the electrons on the outside of an atom, the part of an atom that can come into contact with other atoms. And the inner shell just doesn't come into contact with other atoms. Not usually. Only in the cases of metals do we see, transition metals, do we really see a lot of that. Okay. All right, the octet rule. Atoms try to have 8 electrons in their outer shells. Now, atoms, they're not people. They don't actually want anything, but they have a tendency towards 8 electrons in their outer shells. This is the rule that defines our beginning understanding of chemistry. This octet rule is the most important thing to understand about everything that's going to happen in our science class in the next couple of months. That's why I said super important note here. Dot diagrams. A dot diagram is used to show the electrons on that valence shell. It ignores the inner shells. The inner shells are not relevant when we're doing Lewis dot diagrams. We talked about these a little bit when we were doing Bohr models, but basically, that's not big enough. Let's go with a great big fat dot. Okay, that's way too big. All right, we'll stick with what we had. Okay, so there's a dot here. That's hydrogen's 1 electron on its outer shell. Chlorine, look at the periodic table. Chlorine is going to have 1, 2, 3, 4, 5, 6, 7 electrons on its outer shell. Oh, look, it tells me that right here. So for chlorine, if we were to draw a dot diagram, we would draw 1, 2, 3, 4, 5, 6, and 7. Okay. So once we draw our dot diagram, oxygen is going to have 6. I can prove that. It's right here on the periodic table. Okay, 6. It's the 6th one from the left. 1, 2, 3, 4, 5, 6. Once we draw our dot diagrams, we can tell which of these atoms are going to hook together to form chemical bonds. Okay. Some good examples, we have hydrogen and chlorine, right? Hydrogen has 1, chlorine is missing just 1. Sodium and chlorine, sodium has 1 on its outer shell as well. Okay. Fluorine has 7 on its outer shell. Magnesium has 2, oxygen has 6. So magnesium and oxygen will probably attach together very easily. Neon is a noble gas. It has 8 electrons on its outer shell. It's not going to combine with other atoms. Okay. Let me clear my notes here. So an example of a substance that can't be separated by physical means, a great example of this would be carbon dioxide. Carbon dioxide is a compound where carbon and oxygen are attached using a covalent bond. A molecule, quick review, it's atoms that are connected using these electromagnetic forces. And the valence electrons are found on the valence shell, the outside shell. That's a good intro to the octet rule and how atoms combine to form molecules. I am going to pause I'm actually going to end my recording, and I'm going to go back and show the video again of ionic and covalent bonds.